Okay, I'm going to continue on with the review video. I'm not sure how far I will get, so let's just get to it and see. All right, this picture over here, the problems are about finding the different measures of the arcs, which most of you guys think this is pretty easy. The only thing I did was I found my missing pieces. So I know that this is a semicircle, 180 degrees. So if that angle's 90, that angle has to be 90. So that's the first thing I did. And then I know, same thing over here. I know that ABC is a semicircle, so that's 180. And so I took 180 minus the 52, so I could get that 128 degree angle there. So now that I know all my angles inside the circle, all my central angles, then I can find all the measures of the arcs. So I'm going to just display them, because like I said, this is pretty easy for most of you. Remember, as long as we have a central angle, whatever that central angle is, that's what the arc is. So arc AB is 52. So whatever the measure of the central angle is, that's what its arc is. No special formulas like half arc plus arc. And some of these I did a little adding, and some of them I did a little subtracting. As long as you know whatever the central angle is, that's what the arc is, you're good to go. Okay, this next question, it wants to know the length of each arc. So I know that this is a problem that some of my students struggled with. This is when we set up the proportion. It's just, do we use area down here or do we use circumference? If I want to know the length around a piece of a circle, I need to know the length around the whole circle, so I'm going to need to know about circumference. So that was the first thing I did. I was told that the diameter was 24 units long, so I found my circumference by taking pi times d, and I get the circumference to be 24 pi. And now I'm ready to set up my proportion. So I was told that the measure of angle DOE is 120. So that's what I want to find is arc DE, the length of it. So I take how many degrees it is, 120, out of how many degrees in a circle, 360. What's the length of this arc, X, out of the length around the whole circle? And the length around the whole circle is circumference. And that's why I have 24 pi down in that spot right there. And then because this said round to the nearest tenth, I actually just put this in my calculator with the pi. So I'm just going to show you real quick what I did. I took 120 times 24 pi. I hit enter, and then I went divide by 360, and then I rounded to the nearest tenth. So if I wanted to leave this in terms of pi, I wanted to put the pi in the calculator. I would have just done 120 times 24, got an answer, divide by 360. But because it told me to round to the nearest tenth, then I went ahead and I put the pi in. Okay, this next one wants me to find the length of arc DEA. So I need to figure out how many degrees arc DEA is. So I take 120 plus 90, and that makes my 210. So arc DEA is 210 degrees out of 360. What's its length out of the length around the circle? I cross multiply it and divide. And if I round to the nearest tenths, I get 44.0. Okay, so arc length, area of sector, we set up proportions. Arc length, we use circumference because I want to know the length around a piece of the circle, so I need to know the length around the whole circle. If I want to know area of sector, I'm going to need to know area of circle. Okay, in this set, I needed to know some angles. So the first thing I did was I set up this equation, 4x plus 15x plus 3 plus 7x minus 5 equals 180, because I know a semicircle that those angles add up to be 180 degrees. So I set up my equation and I solved for x, and then all I did was I plugged my 7 into these x's. So when I went to find the measure of angle CRD, I plugged the 7 right there into that x, worked it out, got 108. When I wanted to know the measure of angle DRE, I put the 7 right there into that x, worked it out, got 28. Hopefully you think that is pretty easy. Okay, number 23. This gets into our new stuff, the stuff we've been working on this last packet. So let's just start talking about it and cover up some of this stuff. All right, so I mark as much in the picture as I possibly can when I read the problem. It told me that the measure of arc HQ was 48. It told me that chord HI is equal to chord JK. And it told me that JR is 7.5. So I'm just going to talk to you about things I know. I know that if I ever have a radius or a diameter perpendicular to a chord, that it cuts the chord in half and it cuts the arc in half. So that's how I know that those are equal and those are equal. Same thing over here. I have a radius perpendicular to a chord, so it chops the chord in half. So I know those two pieces equal, and I know this arc gets cut in half. So I know that piece equals that piece. And the reason why I know that all of these are the same length is because it said that this chord is the same length as that. So I know that each of those pieces are all going to be the same. Okay, so just going through this problem. I wanted to know the measure of arc QI. Well, I know it's going to be the same as this one. If this one's 48, QI is 48. Because that arc gets cut in half. It gets bisected. If I want to know the length of HI, I know if this is 7.5, this one's 7.5. If this is 7.5, this is 7.5, and I add 7.5 plus 7.5, and I get 15. And then the next one wants to know the length of ER. This is the tricky one. So ER is what I want to know the length of. I'm going to put a little X there. And with these sort of problems, we did Pythagorean theorem a lot, so I need to try to figure out if there's a right triangle I could work with. Well, there could be if I drew in this segment right here. So that's what I want to do. I want to draw in that segment right there, and then I'm going to be able to do Pythagorean theorem. So I want to know ER. I know JR 7.5. Let's see if I know what EJ is. So you see right here how ES is 10. ES is a radius because it's from the center to an edge. Well, is EJ a radius? Yes. EJ is a radius also. So if ES is a radius and it's 10, EJ is a radius, so it's 10. So I just drew the triangle down here. So I had a little more space to work. And I put down that EJ is 10, and that's because it's a radius just like ES. And then C is the 10. So it's x squared plus 7.5 squared equals 10 squared. Work it out. And I get x to be approximately 6.6. Okay, down here. They started telling me things. They told me that the measure of arc WX is 104. They told me the measure of arc WZ is 88. And then they told me that the measure of angle ZWY is 26. So ZWY is 26. So the first thing I did was I knew if this was a 26-degree angle here, that its arc would be twice the amount. Because remember, we have that formula that says if the vertex of the angle is on the circle, the angle is half the arc. So if 26 degrees is half the arc, then that means the arc must be 52. So I went ahead and I filled that in just so I know what all the arcs are in the circle. And so then I still want to know what arc YX is, so I'm going to add these three together and take that away from 360. And I get this arc to be 116. Once I have that much, then the rest of these questions are pretty easy. So let's look. The first one wants the measure of angle 1. So I'm going to color in angle 1. Angle 1, you can see its vertex is on the circle, so it would be half of its intercepted arc, so it's going to be half of 104. So that's going to be 52. Let me shrink this down a little bit. Okay, next it wanted to know the measure of angle 2. The measure of angle 2 is 26. I know that because it was given to me right here. That one was easy. And then it wants to know the measure of angle 3. So I look at where angle 3 is, and you can see that angle 3's vertex is on the circle. So this angle will equal half of its intercepted arc. So it will equal half of 116, and that makes 58. Okay, moving on to number 25. Number 25. So the way I like to approach these problems is I like to read everything that's in the directions. I like to mark up my picture with everything I'm told and see what else I can figure out before I ever even look at the questions. So I was told that this quadrilateral is inscribed, and I was told that the measure of arc FG is 97. I was told the measure of arc GH is 117. I was told the measure of arc EHG is 164. And then I went ahead and I found every arc in this problem, but there's actually another way I could do this, but I want to go ahead and show you this. So if I know this is 97, and I know that this one's 117, and this whole piece here is 164, then I can find this little piece by taking 164 minus the 117, and when I do that, I come up with that little piece being 47. So then I needed to know what this little piece was. So I went ahead and I added from here to here up and took that away from 360, and that gave me my missing one to be 99 degrees. Okay, first thing it wants to know is the measure of angle E. So let me color in the measure of angle E. Angle E's vertex is on the circle, so it's going to equal half of its intercepted arc. So it's going to equal half of the 117 plus 97. And if we take half of 117 plus 97, we get 107. I'm going to go ahead and put that in the picture. And then it asks what the measure of angle G was. So I can do this two ways, and I'm going to show you both ways. If I want to know the measure of angle G's vertex is on the circle, so it's going to equal half of its intercepted arc. So it's going to equal half of the 47 plus 99. And if I take half of the 47 plus 99, I get 73. But I could have found the measure of angle G much easier if you remembered one of the theorems that we learned. One of our theorems said if we have a quadrilateral inscribed inside a circle, that opposite angles are supplementary. So once I knew that was 107, I could have taken that away from 180 and got that to be 73. But if you don't remember the theorem, then you know enough information just by knowing that these vertexes are on the circle, and so they equal half of their intercepted arc, that you can do the problems that way. Okay, 26. We are told that if we have segments that are tangent and they meet out at an exterior point, that those segments are congruent. So if you have tangent segments that come together to the same exterior point, then those tangent segments are congruent. So I just set 3x minus 6 equal to x plus 10, worked it out, got x equals 8. Okay, so I'm going to use that same information for this next problem. In this problem, I have several tangent segments meeting out at an exterior point, so I know those two equal, those two equal, those two equal. And I knew how long QT was, and how long PT was, and how long SR was, so that's how I knew that each of those were 4, each of those were 9, each of those were 13. And then this wanted me to find perimeter. So perimeter is the distance around an object, so it's 4 plus 9 plus 9 plus 13 plus 13 plus 4. And when I add that up, I get 52. Easy peasy, lemon squeezy. Okay, next one. Measure of angle 2. you can see that angle 2's vertex is on the circle. So if I want to find it, since it's on the circle, I take half of the intercepted arc. I just had to figure out what this arc was here. So I took 360 minus 134. Once I found out that was 226, I do what the formula says, which is take half of the arc. So half of 226, 113. Okay. I'm going to try to do maybe 1 or 2 more problems, and then I'm going to have to stop, and then I'll have to do a third video for the rest of the review. So let's look at problem 29. Problem number 29. This is one of our newer things that we learned in this packet. And this is about a secant and a secant coming together. And so we have this formula where we're supposed to take the whole segment times the outside and set that equal to the other whole segment times the outside. So this is what that looks like. The whole segment of this one is 18 times the outside 5. The whole segment of this one is x plus 9 times the outside. 18 times 5, that's easy. That's just 90. But when I distribute my x, I get x squared plus 9x. And this is actually different than any of them that we did in class. But you have the skills to do this. We talked about earlier this year that whenever you have an x squared in a problem, you have to make one side equal to 0, and then we solve by factoring. So I'm going to move this 90 by subtracting it. That's where this came from. And then I did the little rooftop. I took my 1 times my negative 90, got negative 90. I want the numbers to add to be positive 9. So I had to try to think of numbers that would multiply to be negative 90 and add to be positive 9, which are 15 and negative 6. So then this is how it ends up looking. X plus 15, x minus 6. And then I set these both equal to 0 and solve. If I set x plus 15 equal to 0 and solve, I get x equals negative 15. And when I set x minus 6 equal to 0 and solve, I get x equals positive 6. Well, x can't have a negative length, so the positive 6 is the only answer that I want there. Okay, I am running out of time, so I'm going to have to stop the video right here, and there will be a third video to come. Thank you.